Hi mathematicians, today we're going to talk about measuring angles. So I want everyone to try this do now. Max measured an angle. He said the angle was 4 centimeters wide. Does his measurement make sense? Be prepared to explain why or why not. Take a look at the picture and that prompt, and on your piece of paper, jot down your explanation of whether or not Max's measurement makes sense and why. Okay, let's go back over it. So I'm betting that a lot of you said his measurement doesn't make sense. And if you wanted to explain why, well, yes, from specifically this point to this point, it's 4 centimeters. But what if you measured the angle down here? Then that's going to be even smaller, right? Or, for instance, from these 2 points, even smaller. So we know centimeters aren't a good unit for measuring angles. They're a good unit for measuring length, not angles. Do you know what is a good unit for measuring angles? Degrees. Degrees are our old friends. You've heard about them before because we've talked about them in terms of many different types of angles. So let's review some of our angle vocabulary. An acute angle, I like to say I'm a cute little angle, and it's one that's small, measures less than 90 degrees. An obtuse angle, I always like to say it in that deep voice, is an angle that measures more than 90 degrees, but less than 180. And then, of course, our right angle is the angle that measures exactly 90 degrees. Now, another term we maybe haven't heard as much is a reflex angle. And this is an angle that measures more than 180 degrees. So notice also this is different than obtuse, right? Obtuse was more than 90, but obtuse had to be less than 180. A reflex is measures even more than 180 degrees, less than 360, because that would be a full turn. Okay, and then this is a new vocab term, and the name really fits the picture. A straight angle, say it with me, straight angle. And if you picture that, right, it's an angle that falls on a straight line, and it measures exactly 180 degrees. So now let's explore these degree measurements a little bit more. So you know that a full turn, right, an entire full turn angle, that is 360 degrees. So if we wanted to actually pay attention to smaller measurements, right, like a half turn, we know that that would put us at 180 degrees, or that's that straight angle we were just talking about. And that we can get that, right, by taking 360, dividing it by 2, would give us 180. What if we cut that 180 in half? Can you predict what measure this would be? That, you're right, is a 90-degree angle, also known as a right angle. Very good. So if we cut that in half, oops, sorry, I got ahead of myself. Cut that in half, 180 would give us 90. And now that we know that this quarter turn is 90 degrees, right, we can keep going, just skip counting by 90. So 180 plus 90 more, a three-quarter turn is 270 degrees. And if you did plus 90 more, that gets us all the way back around to this 360 degree angle. So these four are very important benchmarks to know. And you probably already have some of them memorized, right? You've heard of a 360 degree turn. You've heard of a 180, maybe in snowboarding or ice skating or skateboarding, one of those sports, right? We talk about 360 degree turns or 180 degree turns. You know right angle's 90. Perhaps you already knew that a three-quarter turn was 270 degrees, but add that one to your list to memorize. Or if you ever forget it, you could simply add 90 degrees onto 180 and get it that way. Okay, so today we're going to use a special tool for measuring angles, and it is a 360 degree circle protractor, which we'll learn more about protractors later this week. But right now you will have a circle that looks like this. It even has more than the labels we just did, right? Because it also shows that half of 90 degrees would be 45 degrees. So this one's showing every single 45 degree angle. So when you go to measure an angle using this full circle tool, first thing you want to do is estimate the angle. And the reason we do that is so that we make sure we have some sense in our head of where we want this angle to be. Right? So if I'm looking at the angle right here in this picture, sorry, this angle, if I make an estimate, I already know it's less than 90 degrees. Maybe I want to say, my estimate for that would be maybe about 50 degrees. Right? That's a reasonable estimate. Maybe your estimate's exactly 45 degrees. Your estimate's definitely going to be significantly less than 90, but greater than 0. Okay, so step 2 is really important. Rub your ears so I know you're listening. That's when we line up the 0 degrees mark on the measurer with the side where the arc begins. So you can see that in this picture. Let me pick a different color that stands out more. I took the 0 degree mark and made sure it lined up with the side of the angle where the arc begins. Also, you want to make sure the center of the measurer, the center of the circle, is on the vertex of the angle. Otherwise, you're going to get an incorrect measurement. And then, step 3 is just to look in the direction of the arc. So we follow the arc to here. Okay, it lands here. And then read the degree measure where the other side of the angle crosses the angle measurer. So at this, the line crosses at about 45 degrees. So we can conclude this angle is about 45 degrees. And most importantly, you want to think, does my answer make sense? Well, yeah, if we estimated already that it was going to be about 50 degrees, and now I got 45 degrees when I use the measurer, that seems reasonable. So I know I'm on the right track. Let's just show another angle just for practice. I'm going to switch my color to purple. So I'm going to put this on the measurer. Pretend I had to measure an angle. I'd line up with 0, vertex at the center, and say the angle crosses here. Right? Well, now you do have to use your estimating skills again, because it was nice on this last example that it crossed pretty much right at the 45 mark. Here it doesn't cross right at the 90 mark. So we have to use our estimating skills. We know that between 90 and 35, there are 45 degrees. So you now have to think of what's reasonable. So if I cut 45 in half, that would put me like right about, I think this is about the in half mark, cut in half, and 45 degrees cut in half would be 20, 22, 23, right? Actually 22.5 if we're being exact, but that's okay, 22 or 23. So I think this is about 22 degrees away from 90. So maybe I want to say this is, I think it's reasonable to say this is maybe 17 degrees away from 90. Again, you don't have to be quite that precise as long as you're not saying, oh, this must be 135 degrees. No, it's clearly not, right? Or you're not saying this is 132 degrees. No, it's clearly not. So I'm going to say maybe this is like 17 to 20 degrees away from 90. So maybe I want to estimate this at, if I said 20, 90, 100, 110. Maybe I want to say that's about 110 degrees. As long as you're in the right ballpark with this angle measurer, you have you can use your common sense to make those estimates. But just keep in mind our benchmarks here, that there are 45 degrees between each of these benchmarks, and use that to help you accurately measure angles with this tool.